Welcome to lesson 2.5, Reason Using Properties from Algebra. So the goal with this lesson is to use our algebraic properties in logical arguments. And we already looked at rules of logic or laws of logic in geometry, mainly tying to the law of detachment and the law of syllogism. Now we're going to look at other buildups to logical arguments, and again, based on this title, it will be based on algebraic properties from Algebra 1. So we have a few different properties here to just briefly refresh on. The addition property, which states if A equals B, then A plus C would equal B plus C. So if we're adding the same value to them, they're still equal. Subtraction property, if A equals B, then A minus C equals B minus C. So we can subtract the same value and they're still equal. The multiplication property, if A equals B, then A times C equals B times C. Division property, if A equals B, then A divided by C equals B divided by C. With one sub-rule there that C cannot equal 0 because division by 0 is undefined. And then we have the substitution property, which says if A equals B, then A can be substituted for B in any equation or expression. And then the last property we're looking at is the distributive property, which is the one that states if we have A multiplied by the quantity B plus C, that equals A times B plus A times C. So you're distributing the A to both parts inside the parentheses through multiplication. So now we're going to complete the logical argument by giving reasons for each step. So we're looking at the math over here on the left, and from the first step to the second step, we're going to give the reason, which would be one of our properties. So in this case, we have our initial given statement, 8x minus 34 equals 6. So the first thing is always a given. So our answer to the first line, our first step in a reason, is just stating what's given. Then from this first step to the next step, what I noticed is they added the 34 to each side, so 8x equals 40. So they're undoing the 8x minus 34. They're trying to solve for x by adding 34 to each side. So we're left with 8x equals 40. So what happened between the first and second step was the addition property of equality. So our properties of equality, our addition property, they added 34 to each side. So A plus C equals B plus C. Then 8x equals 40, and our next line is x equals 5. So what did they do from the second step to their final answer? They divided each side by 8, so that would be the division property of equality. In B, we have our given statement, 5 times the quantity x minus 3 equals 4 times the quantity x plus 2. Then, in between line 1 and 2, they distributed the 5 and the 4, so they used the distributive property. Then, our next line was 5x minus 15 equals 4x plus 8. And then we're down to x minus 15 equals 8. So what they did was they subtracted the 4x from each side. 5x minus 4x left us with this x. So that was the subtraction property of equality. And then in the final step, to undo the subtracting 15, they add 15 to each side, giving them x equals 23. And the reason they were able to do that was the addition property of equality. So by being able to write out reasoning for each step, you are providing a logical argument for why that mathematics works. So example 2 says solve each equation, write a reason for each step. So we have 7x minus 11 equals 4x plus 19. So the first thing I did was subtracted the 4x from each side. So that was the subtraction property of equality. So I wrote my subtraction property. Then I added 11 to each side, giving me 3x equals 30. So that was the addition property of equality. And then I divided each side by 3. So x equals 10. So that was the division property of equality. So we're solving for the variable and then writing our reasoning for each step on the right. In B, first thing we had to do was distribute the 14 and the negative 7. So I'm left with 14x plus 14 equals a negative 28 minus 7x. And that was due to the distributive property. Then I added the 7x to each side, so the addition property of equality, and we have 21x plus 14 equals a negative 28. Now to solve for x, subtract 14 from each side, so that was the subtraction property. That left us with 21x equals 40, or a negative 42. Divide each side by 21, x equals a negative 2, and that was the division property of equality. And now we're adding 3 more properties. The first one is the reflexive property of equality. So the reflexive property of equality says for any real number A will always equal A. So something always equals itself, the reflexive property. The symmetric property of equality for any real numbers A and B, if A equals B, then B equals A. You can just flip the order, they're symmetrical. So we can flip what's on either side of the equals. And then the transitive property of equality for any real numbers A, B, and C, if A equals B and B equals C, then A also equals C. So if A equals B and B is equal to C, we can get rid of that repeated B and A equals C. And then there's a subnote here that says these properties are true for real numbers, segment lengths, and angle measures. So these properties work in all those cases, dealing with just simple arithmetic or real numbers, dealing with measurements and segment lengths, or dealing with angle measures and degrees. So looking at example 3, we're going to apply these 3 new properties, plus the ones earlier. So use the property to complete the statement. So our addition property of equality says if RS equals TU, then RS plus 20 would equal TU plus 20. As long as we're adding the same thing to both sides of the equal sign, they are still equivalent. The substitution property of equality states if A and B are equal, then we can substitute them. And in this case also, if A equals 20, then 5 times A will equal, well, that's 5 times 20. We're substituting the value in for A, which would also be 100. And then the transitive property of equality, if the measure of angle E is equal to the measure of angle F, and the measure of angle F is equal to the measure of angle G. Then based on the transitive property of equality, we could state that the measure of angle E is equal to the measure of angle G, because both of those equal the measure of F. And then moving into our final concept is a word problem. So our word problem for example 4. As you begin a free fall, you have an acceleration, or you're accelerating in a downward velocity. Because of wind resistance, the acceleration slows your velocity and eventually you become constant. This is called your terminal velocity. So when you're falling and you hit that point where you stop accelerating and you've reached your constant velocity, that is called the terminal velocity. Terminal velocity of a typical skydiver is around 56 meters per second. Formula for distance traveled in t seconds by a skydiver falling at this velocity is represented by d equals 56 multiplied by t. So our distance would equal the 56 meters per second multiplied by time, which is our seconds. So the skydiver reaches her terminal velocity of 56 meters per second and then continues free falling for 12 more seconds. How many meters does she fall during these 12 seconds? So we're simply using the substitution property, and we knew our time is 12, so we're replacing the t with 12. 56 times 12 gives us our distance being 672 meters. Now they want us to solve the formula above for t, write the reason for each step. So I did not write my reason there, but just one second. So if we are looking to solve for t, like I said, I did not put my steps over here, but we start with d equals 56 times t. We divide each side by 56, so our reasoning here would be the division property of equality. And to solve for t, we would have t equals the distance d divided by 56. So if we're finding the time it would take to drop 840 meters, moving at our terminal velocity of 56, we would do the 840 divided by the 56. So then what we end up with for our final answer, 840 divided by 56, would give us 15, so our time would be 15 seconds. So I apologize, that got cut off on the bottom here, but the last part would be 840 divided by 56, so t would equal 15 seconds. So what we're really doing today is not any new algebra or mathematics. It's just applying the reasoning based on properties that you've covered in the past few years and why we logically are able to go step by step to reach a conclusion. So seeing going from the given to your final solution and writing out a justification for each step along the way is the beginning process of writing geometric proofs.